Hey there, mathematicians. This is lesson 4.4, factoring quadratic expressions. This is actually a review lesson, but factoring is often something that people struggle with, right? These are actually the factoring patterns that you would have learned in Algebra 1. We'll learn a couple more here in this chapter later. So factoring is rewriting an expression as a product of its factors, and then we're going to use that to actually solve them here. So the greatest common factor, like you know, is a common factor of the terms in the expression. So the largest thing you can take out of all the terms. So like here, we have two terms, 4x and 24. The largest number that goes into 4 and 24 would be 4. So then if you take 4 out of 4x, you're left with x. And out of 24, you're left with 6. And now you can see what's left inside, x plus 6. That only has a factor of 1. So this is fully factored. 5x squared plus 10x minus 25. So now we have three terms. The largest number that goes into 5, 10, and 25 would be 5. So if you brought 5 out of x squared, you're left with x squared. Plus 5 out of 10x, you're left with 2x. Minus 5 out of 25, you're left with 5. Because remember, if you were to multiply this back out, right? If you were to go through and then distribute this, you should be right back to where you started. Number 3, we have 27, 9, and 18. So the largest number would be 9. But then also, I noticed there are G's in every group. The first group has 3 G's, second group has 2 G's, and the third group has an invisible 1 G. So I can also take a G out of all the groups. So I end up with then inside, if I take 9G out of everything, I've got 3G squared minus 1G, put the 1 or not if you want to, plus 2. All right, so that's a little review on greatest common factor. Then we learned about quadratic trinomials. So they're in the form ax squared plus bx plus c. When a is equal to 1, you do the riddle process. I call it riddling. So x squared plus 5x plus 6, we know would have come from two binomials. To get our x squared, you would have gone x times x. And then remember the pattern is what multiplies to give you positive 6 and adds to give you positive 5. Well, I know if I'm going to multiply and get a positive and add and get a positive, both my signs are going to have to be positive. So then I can think of the factors of 6. I could do 1 times 6 or 2 times 3. So then looking for the pair that adds up to 5 would be 2 and 3. So x plus 2 times x plus 3. And again, if you multiply this back out, you would be right back to where you started. So number 2, we've got a quadratic trinomial. So now we have x and x. Multiplies to give me a positive, adds to give me a positive. They both have to be positive. Multiplies to give me 16, adds to give me 10. I can do 1 and 16, 2 and 8, 4 and 4. So the pair that adds up to 10 would be 2 and 8. Right, next one, we've got x squared minus 13x plus 36. So we go x and x. Since they multiply to give you a positive, they have to be the same. But then sames that are going to add up to be a negative are both going to have to be negative. A negative times a negative is a positive. A negative plus a negative is a negative. Let's see. Multiplies to give you 36, adds to give you negative 13 would be 4 and 9. That one that's off the charts down there, number 4, says x squared minus 5x minus 14. So we're getting two binomials, x and x. If multiplies to give you a negative, you know one number has to be negative, one number has to be positive. So this would be 7 and 2. I have to make sure I get them in the right spot. So this would actually be negative 7 and positive 2. Because 2 times negative 7 multiplies to give me negative 14. 2 plus negative 7 adds together to give me negative 5. All right, sometimes, so when you're doing problems, you always do a greatest common factor first. So this first one, and you also want your first term to be positive. So this first one here, I want to factor out a negative 1, right? So when I bring a negative 1 out of all the terms, then I'm left with x squared minus 13x minus 12. So then what I'm left inside with is a riddle. So then I got to keep So I have the negative 1 on the outside. I have a riddle. I have x times x. Multiply gives me a negative, means I need to have one of each side. Sign. Multiplies to give me negative 12. Adds to give me, oh wait, I forgot to change that sign. Woo, I just caught myself. That should be a positive, right? That should be a positive because I divided this negative 12 by negative 1, so that should be a positive 12. So then you actually end up with two negatives in here because they have to be the same that add up to a negative or both negative. I caught my mistake because when I was looking at the factors, it wasn't going to work out. So then multiplies to give me positive 12, adds to give me negative 13, would be negative 1 and negative 12. So on number 2, always greatest common factor first. So here I can see I can bring out a 5. If I bring out a 5, I've got x squared minus 1x minus 2. So that's a riddle. So I have 5 on the outside. Riddles come from two binomials, x and x. Multiplies to give me a negative. I know one of each sign. Multiplies to give me negative 2. Adds to give me negative 1 would be negative 2 and positive 1. So always greatest common factor first. All right, so now we can see we've got our quadratic trinomials where a is not equal to 1. And if I look here, a is 2, but 2 doesn't go into 11, so that's not going to work out. So I need another method. There are lots of methods. If you look them up, I'm going to go with slide and divide. So what you do here, it's just this little pattern that makes it work out. You slide the 2 to the end and you multiply. So this becomes x squared plus 11x plus 24. Then you take that and you riddle it. So multiplies to give me a positive, adds to give me a positive is double positive. Multiplies to give me 24, adds to give me 11 would be 3 and 8. But if we multiply this back out now, we're not back to the beginning, so we're not done. So this is why it's called slide and divide. Now you take those numbers and divide them by what you split by. Then you reduce them if you can. You can't reduce 3 over 2. 8 over 2 would be 4. And then you rewrite them. So the ones that didn't become integers, so like this one is x plus 4, you take the bottom number, you move it in front of x. So x plus 3 over 2 is the same thing as 2x plus 3. That is slide and divide. If you multiply that back out now, you would be back to 2x squared plus 11x plus 12. So again, what you do is you take that first number and you put it on the end and you multiply. So this becomes x squared minus 4x minus 12. You then riddle that. So we're going to have an x plus and an x minus because the third term is minus. So then what multiplies to give us negative 12 and adds to give us negative 4 is going to be positive 2 and negative 6. So slide and divide, we would now change this by dividing by 4. Reduce them. So this is like x plus 2 over 4 is 1 half. 6 over 4 is 3 halves. So then move your denominators in front of x. You have 2x plus 1 times 2x minus 3. If you multiply that back together, you're going to be right back where you started. So it's just this pattern that always works for these slide and divide. So that's when your a is not equal to 1 and you can't just factor it out. So that third problem down there says 3x squared plus 7x minus 20. So it's a slide and divide because 3 doesn't go into 7 or 20 for that matter. So 3 is at the end. So we're looking at x squared plus 7x minus 60. So x plus, x minus, because we're multiplying to get a negative. What multiplies to give me negative 60 adds to give me 7. Would be positive 12 and negative 5. Slide and divide. So now we divide by what we slid by, which would be 3. So 12 over 3 becomes x plus 4 times 5/3 doesn't reduce, so that'd be 3x minus 5. Slide and divide. So again, there's numerous methods, if you look it up, that work for those. That's the method that I'm going to use in class. All right, difference of two squares. When you're subtracting two things that are squares, you always get two binomials, one addition, 1 subtraction. Whatever you're squaring on the first term over here is what's going to go in the first term. And whatever being squared in the last term there goes in the last term. Because then what you can think about what would happen is those middle terms, like when you multiply it out, would always cancel out. So like x squared minus 16 is a difference of 2 squares. So I get 2 binomials, 1's addition, 1's subtraction. X squared, what's being squared is x. 16, what's being squared is 4. So then you can see how you have a 4x minus 4x, so that cancels out, and that's why you only end up with 2 terms instead of 3. So like number 2, it's a difference of 2 squares. So 1 addition, 1 subtraction. 4x squared, what's being squared would be 2x. 25, what's being squared is 5. So 2x plus 5, 2x minus 5. 9x squared minus 49y squared, difference of 2 squares. So 9x squared, you're squaring 3x. 49y squared, you're squaring 4y. So 3x plus 7y, 3x minus 7y. Difference of 2 squares. All right, so as always, you always got to look for that greatest common factor first now. So here you can see greatest common factor would be 4, which then leaves inside x squared minus 4. In that case, that's not done. X squared minus 4 is a difference of 2 squares. So I have 4, x plus 2, x minus 2. Number 2, I can see the greatest common factor is 10. If I bring out a 10, I have x squared minus 16, which also happens to be a difference of 2 squares. So I'd have 10, x plus 4 times x minus 4. So you always factor until you can factor no more. 18 and 8, the largest number I could bring out would be 2, which leaves inside 9x squared minus 4. Look at that. It happens to be a difference of 2 squares. So we have 2 times 3x plus 2 times 3x minus 2. Woo. So now we're going to throw it all together, which is usually the harder part. So you always look for the greatest common factor first. Always, always, always. So first one here, greatest common factor is 3. 3 goes into all these. So if I bring out a 3, I'm left inside with x squared minus 8x minus 9. And then I look at what's left behind. That is a riddle. So I would riddle it. So multiplies to give me a negative. So I go x plus, x minus. Multiplies to give me negative 9, adds to give me negative 8. It would be positive 1, negative 9. Now what's left inside can't be factored, so that is done. Number 2, I can look and see greatest common factor would be 2. If I bring out a 2, I have 2x squared minus 11x plus 5. So I look at what's left behind. That is a slide and divide. So I'd have the 2 hanging out in front of my slide and divide. So let's see here. 2 is going into the end, so this is going to be a 10. So what multiplies to give me 10 adds to give me negative 11. It's going to be x, let's see, minus 10, x minus 1. So then I'm looking at, I got to slide and divide. So divide them back by 2. So I get 2, x minus 10 over 2 is 5. And 1/2 doesn't reduce, so that would be my 2x minus 1. And then, let's see here, 64x squared minus 16. Greatest common factor there would be 16. If I bring out a 16, that leaves inside 4x squared minus 1, which is a difference of 2 squares. So I have 16, and then my difference of 2 squares would go 2x plus 1, 2x minus 1. So that is just a quick little review on the factoring patterns that we have covered so far in your other math classes.